Hi, today we'll look into acid and bases and see how do you recognize if something is a base or something is an acid, or conjugate base or conjugate acid. So first we'll start with what does it mean when we say acid. Acid could be a proton donor, so that means base could be a proton acceptor. But then there's another definition to it. So that could be acid could be electron pair acceptor. That means that your base can be an electron pair donor. Yeah. To make it more easy, you can always say that something that has a positive charge is an acid, and then something that has a negative charge is usually a base. Now how does it make sense? Well, if something has a negative charge and you're calling it a base, well, if you want to satisfy that negative charge, it needs something that's positive, so that's why it's a proton acceptor. Also, because it has a negative charge, it wants to, let's say, wants to give away that negative charge to balance itself. That's why it could be an electron pair donor, so it's giving away those electrons. Similarly, if we talk about an acid, if acids usually have a positive charge on them, that means that to stabilize themselves, they want to lose that positive charge. That's how they become proton donors. And also, there's another way to satisfy the positive charge, to gain electrons. So that's why they accept electron pairs. So electron pair acceptor makes it a base. Now below over here, we'll try naming them as conjugate base, acid, which is an acid, which is a base, and the conjugate base pair as well. So this first species, this one would be a base. And how do I know that? Well, because it has a negative charge. That's the easiest way to know it, because negative charge species is a base. So the other one, the water, would be acting as an acid over here. Now what about the other two things over here in our product side? Well, every reaction has two conjugate pairs. So that means that if this base will have an conjugate acid with it on the other side of the equation. So that means if you look at these two, they seem quite similar. So they make one pair. The other pair would be of water with OH. So these are our two conjugate pairs. That means that if with our base, this is our conjugate acid. So for water, which is our acid on our reactant side, OH negative would be our conjugate base. So these are two conjugate base pairs. We'll move on to the second one. We'll try naming this one now. So, sorry. Over here, because NH2 has a negative charge, so anything that has a negative charge is our base. So we'll call this a base. Automatically, this is our acid. Now the conjugate base pairs. This looks like makes a base pair with this species, and acid will make a pair with this species. Now this species is gonna be called conjugate base because it links with an acid. So you have one base and the other one is supposed to be an acid, and vice versa. And NH3 would be our conjugate acid. Another one. Well, over here the negative charge is on this species, so this one is our base. So the other thing automatically becomes our acid. This base pairs up with this, so this thing is our conjugate acid, and we are left with conjugate base. Because this is an acid, so it makes a pair with a conjugate base. Now moving on to the last one. Well, over here nothing has a negative charge, but NH3 over here has lone pairs. So when anything has lone pairs, that could also be considered as it has more of the negative charge on it. So we consider it as a base as well. So you could either have a negative charge or lone pairs. That means the same thing because it has more electrons to it. The other thing would be an acid. This acid pairs up with this, which would be a conjugate base, and then this base bond has a conjugate base pair, which is NH4, which is our conjugate acid. And also, if you see over here, it has a positive charge. What has a positive charge? An acid has a positive charge. So this one is our conjugate acid. Now, if you want to put arrows on it, you can always put arrows to make more sense out of it. So for the first one, your O negative, so it's the negative species that always attacks. So negative species won't satisfy itself, so it's gonna attack on the hydrogen. So that's on the hydrogen. And then this bond right here, oxygen is gonna take electrons from here, and then this becomes OH negative. That's how it gets a negative charge on itself as well. For the second one, because the negative species attacks, so this is gonna attack on the H, it's gonna become NH3, and then this lone pair is gonna go to carbon over here, and that's how it gets a negative charge. The next one, so the negative species always attacks. So if it's a negative species, it's gonna attack on something that's positive. So it's gonna take hydrogen. So hydrogen comes at H plus. So hydrogen comes at H plus. That means it comes as a proton. It doesn't take its electron with it. So you have those excessive electrons. So those electrons go to oxygen, and that's how oxygen gets a negative charge. And then for the last one, these lone pairs. So lone pairs can also attack. So lone pairs are like electron lone pairs. So it's a negative charge, going to attack on H positive, and then you have, so H is going to come as H positive, right? So it doesn't carry its electrons with it. So those excessive electrons are gonna be taken up by oxygen, and that's how oxygen gets a negative charge over here. But over here, you see how NH4 has a positive charge. That's because it bonded with this hydrogen. H positive, not hydrogen, H positive. And also, if your arrow is, if you don't know how to read the arrow, so let's say over here, let's say for the last example that we have, the arrow goes from, it's going from the bond to the atom. So whenever an arrow goes from the bond to the atom, it means that it's breaking that bond. So if you see over here, this bond gets broken down. So if your arrows ever go from bond to atom, that means breaking the bond. So for the rest of the examples, it also makes sense. So let's see over here, the arrow went from the bond to the oxygen. So you broke that bond. So the oxygen over here doesn't have that H anymore. Similarly over here, the bond went from the arrows went from the bond to the carbon. So it lost this hydrogen over here. And then over here, you lose this hydrogen because the arrow is going from the bond to the oxygen. And that's it.